Section 2 of Chapter 14 is all about angles. And you can see there's a ton of vocabulary here. I'm going to go over that as we do the examples. So, name a right angle off of this diagram. And a right angle is an angle whose measure is 90 degrees. What does that look like? A regular corner. You know, one of those fourth shapes. On this diagram, there are 4. There's one, and that is angle CD. Hold on, I'm going to change that back to a pencil, but I'm going to make it blue so it matches up. That is angle CDF. Angles are named with 3 letters, and the symbol I wrote before the C is the angle symbol. And yes, you have to write the angle symbol. Otherwise, if you just write CDF, I don't know if you're talking about angle CDF or triangle CDF. Symbols are important. So, angle CDF. It's kind of like if you just say Mr. Refner, but you don't give me any other clues. I don't know if you're talking about the science teacher, Mr. Refner, or the phys ed teacher, Mr. Refner. So, this is just giving a proper name to something, that angle symbol. CDF, because we can go from C to D to F. You could also do FDC for that angle. What you cannot do is any other combination of those letters, because C isn't connected to F. So you have to travel through D. And you're going to find, as we name all of our angles here, D will always be the middle letter because, well, we're always going to travel through D. That is not the only right angle. CDA is a right angle. And you don't necessarily have to write all of these down, but I'm going to show them all to you. ADE is a right angle. ADE. And angle EDF. Is a right angle. So there are 4 right angles in that diagram to choose from. You only had to pick one. Naming an acute angle. So acute is an angle whose measure is between 0 and 90. So it's smaller than that. Smaller than what we just did. There are 2 acute angles on this diagram. Angle ADB is acute. It is definitely smaller than 90 degrees. And angle BDE is also acute. Obtuse now. Obtuse is an angle between 90 and 180. So it's bigger than a right angle, but smaller than a straight line. There are 2 of these. As I highlight that, you can see that's bigger than 90, but not a straight line. So that is angle CDB. But that's not the only angle like that. Let's go with pink. Angle FDB is also an obtuse angle. A straight angle is an angle whose measure is 180 degrees. It's a line. So there's one straight angle, angle CDE, and the other on this diagram is angle ADF. Now comes the harder part. A pair of complementary angles. So we look up here in our definitions. Complementary is two angles whose sum is 90 degrees. Sum means add. So it's two angles that come together to make 90 degrees. How you're going to find that in a diagram is you're going to look for a right angle. So there's a right angle that's split up in the middle somehow. This one I just highlighted isn't. That's just a clean right angle. There's nothing going on in there. If we look at this right angle, however, we can see there's definitely something hanging out in the middle there. So the two angles that are made here, pink to blue, then blue to pink, angle ADB and angle BDE, combine to be the pair that are complementary. So it's angle ADB and angle BDE. That is one pair. Let me erase that B and rewrite it so it looks nice. That is one pair of complementary angles. Please pay careful attention to your assignment and the test. You may be asked for two pairs or more. Make sure you give the complete number of pairs. I just need a little more space here. Now, we're going to name a pair of supplementary angles. So supplementary are two angles who add up to 180 degrees. To find these on a diagram, what I want you to do is find a line. Any line will do. Pick a side of that line. So I'm going to go below it. Is there anything at all down here? Yes. This drops through it. That means, if I get rid of that circle for a second, that angle CDF can pair up with angle FDE to be supplementary. Okay. Now, unlike the complementary angles, there are more pairs of supplementary angles on this diagram. I'm not going to go over them on the video, but if you'd like to look for them and ask me about them, you may absolutely do so. Okay, now give me a second and I'll tell you. There's another 1, 2, 3, 4, 5 pair of potential supplementary angles here. So if you think you'd like to take a stab at finding them, you can absolutely ask me about it and I will be happy to talk about it. Last example here says, name both pair, so both meaning two pair, of vertical angles, and then we're going to do some more. So real fast, we got to pop up here to look at a definition. Vertical angles. Angles formed by the intersection of two lines. So here are two lines. Pay very careful attention. Vertical angles are opposite from one another. Angle 1 and angle 3 are vertical. And you can see this is another new way of naming angles. Sometimes they will just have a number in them. In that instance, you can get away with saying angle 1, angle 3, angle 2, angle 4, whatever. 1 and 3 are easy, I think, to see they're vertical because when you hear the word vertical, you think up and down. And 1 and 3 are absolutely up and down from each other. However, angles 2 and 4 are also vertical angles. Because the definition of vertical angles is a pair of angles formed by intersecting lines. Vertical angles are congruent. Congruent means the same. So 1 and 3 are the same. 2 and 4 are the same. So, if angle 1 is 105 degrees, find the measure of the other three. Well, angles 1 and 3 are the same thing. So angle 3 must also be 105 degrees. Now the question is, what are angles 2 and 4? To do that, I want you to look and think about this line and ignore everything below it. So I can't really do that without putting a square or something goofy in here that's not quite going to work. But, you know, for the moment, just pretend this doesn't exist down here. Okay, it's nice and out of the way. So we've got ourselves a line that has two angles on it. Every line has 180 degrees on it. So the whole thing is 180 degrees. I know this part is 105. The question is, what's left? Well, I can do 180 minus 105. That is 75. I can't do it vertically here because I'm at the bottom of a page and it won't let me write. If I know the whole thing is 180 and that the top part's 105, the bottom part must be 75. And if angle 2 is 75, then angle 4 must also be 75 degrees. Now, I want to show you one more thing because I know this is going to crop up in your book. So, let's pretend this diagram didn't have angle 1 here. Instead, there was a line segment, a ray shooting off. On this diagram, the way I've drawn it now, there is only one pair of vertical angles, 2 and 4. Let me also go in here and name these. This is now 1, this is now angle 5. Angle 3 is not vertical to anything because opposite angle 3, the part that looks like it should be vertical, isn't a single angle. It's been split into two. So those are no longer vertical. Yes, angle 1 plus angle 5 would be the same thing as angle 3. But when we say vertical angles, we're strictly talking about a pair of angles. We can't say 1 and 5 combined are vertical with 3. We're only allowed to say something like 2 is vertical with 4.